Yeah, g'day guys, Mark here, and welcome back to my channel. Now if you've been watching carefully, you'd know that I have got a CNC rotary table, and I like to make up the adapters so that I can use my Schaublin lathe collets for tool holding in that rotary table. So last week I made up this pull tube, or draw tube, which looks fabulous, except I totally screwed up the thread. So I'm going to have to make another one of those, and I also need to make the adapter for this end to guide the collets with this taper on it. Right, the first part I'm going to make is the spindle nose adapter, which fits into the front of the rotary table here. It's a pretty simple part made out of cylindrical surfaces with just 4 holes counterbored in the front for the mount bolts. If you're interested, there's a link to a 6-month trial period of Onshape Pro down below. So I bought this slug of steel. It's the steel that's made for case hardening. And yeah, that drill was a bit too short for what I was doing, but as long as you're real careful, once the flutes get kind of buried, as long as you're careful to keep it clear, it kind of works. So next, I'm going to need to bore that hole out to 32 millimeters. Since that tool I made for the thread is mounted on a tool holder, which is long enough, I guess I'll just use that. So I'm just trying to sneak up on this clearance. If I've measured this right, I should have 31.7 millimeters right now. So 0.32 to go. I probably want 2 100ths of clearance for the collet to slide in. So I've set my micrometer on the collet. I'm going to want 2 100ths of clearance, so I need to go another 36 100ths. I'll just duplicate that measurement and just double check it. That end up 1 100th tighter. As snap gauges go, these Mitutoyo snap gauges are pretty nice. Now I'm 1 100th in the other direction. I do struggle to get repeatable dimensions below about 100th with these things. Right, since this is the final pass, and I'm going to be cutting away this first bit on the taper anyway, I can stop here and just double check the dimension. Okay, that's a wee bit looser than I'd like, so I'll take 2 100ths off that. Okay, that fits really nicely, but I'm hitting the swarf. There's a ball of steel wool back in there. Right, next up, I'll start roughing in the taper. I'm just bluing up a collet just to see how things are going. I should still have 2 millimeters to go, and I'm not really happy with the quality, the surface finish with that insert. So I think I'll switch out to one of those high positive rake aluminium inserts. See how that works. Seems to be touching around the middle of the taper. Okay, that surface finish is looking better. Right, still sneaking up on that final dimension. Still not going over the full distance, but it may also be that I have a very slight lip on that. Oh wait, I just rechecked the specification and it's not supposed to be exactly 15 degrees. It's supposed to be 15 degrees with a tolerance of between -3 and -8 minutes. So I need to slightly steepen that angle. It needs to be 14 degrees, 0.916. Okay, this is the last pass. Take it out to 40 millimeters. That looks a lot better. Now when I ordered this chunk of steel, I only need, I think, 68 millimeters, but I gave it a couple of millimeters of cleanup allowance, and they delivered closer to 74. So even with it cleaned up, it's still at 72. Now, rather than facing that extra 4 millimeters away into swarf, I think what I'll do is I'll leave a raised boss around the collet hole, so that gives a little more clearance for tools when I'm working with the collets. Right, well that's all I can do from that side. Now I've got to flip it over and do my best ever job of accurately dialing that in to turn away the rest. Okay, with the run out not remaining even, I suspect I've got a little bit of grit or something under one of the jaws. Let me just quickly try the run out on the face. It would appear that I've got something under these jaws maybe. I'll take it off, clean it, and try again.
Tomorrow for sure.
I've switched out to the micron reading clock. Of course, chasing microns is always a bit of a fool's errand, but let's see how close I can get. Ideally, I'd like the run out to be within about 5 microns, I think. So like this, my run out here is within about 4 microns, 3, maybe 4 microns. And down here, the run out is within 3/10,000th of an inch. Not sure if I'll get it any better, but I'll have a bit of a play with it and come back. Okay, I'm now guessing that this is about as good as I'm going to get it. I'm still getting probably 2, maybe 3 microns on the run out in this direction. And on the bore, I've got 2, maybe 3/10,000th of an inch. I think that's as good as I'm going to get it. A lot of metal to take off here. Need to go down from 99 millimeters to 60. Now this bore is nominally 60 millimeters, but let's just check what it actually measures at. Now I'm going to need a pretty accurate final dimension, because this boss is what centers my collet. So I'll just make sure my micrometer is set up okay. It's zeroed nicely at 50 millimeters, but since I'm going to be aiming for a 60 millimeter nominal, I'll just put some gauge blocks together and let's give them a double check at 60. So it looks like the micrometer is measuring 1/100th of a millimeter over at nominal. This felt like quite a hard fit, so I doubt that measurement. Given the high quality of this Nikken CNC rotary table, I find it highly, highly unlikely that that bore is under nominal. I would assume it's almost exactly 60, and any measurement error I measure below that is probably a measurement error. So let me try that again. Okay, that looks more like it. So that's making about 5 microns larger than the nominal, and that seems like quite a realistic number. I'll do a couple more double checks, but that's kind of what I would expect for this sort of quality of tooling. Basically, that 60mm bore is pretty much dead nuts on nominal. Because my bores come out at 1/100th over, I'm aiming for between 2 and 3/100ths under the 60mm on the shaft. Right, this is the final pass, hopefully to my target dimension. Okay, that didn't chip break as well as I hoped. So how did it turn out? Remember, I'm aiming for a dimension of 3 to 4/100ths under 60mm. So at that end, I've got 4 under, and at the front, okay, a bit of a taper. Here I've got 2 under. So I'll just touch that off with the emery cloth and just maybe take just a little bit more off this end. Okay, that's just coming up on 3 under. What I'll do, I'm going to leave the part in the chuck, just mark how it came off, and offer it up to the rotary table, including the chuck. All right. Right, I was just going to pop it out of the chuck when I realized I still haven't done the chamfer on this end yet, and I can probably do a clean-up cut across that face as well. But that cleaned up quite nicely. Right, this is the last lathe operation, just cutting that internal chamfer. Oh, nice. No marks around the edge there. Oops, I've mounted all of this too close to the end of the table and run out of travel. So I'm going to have to move my vise and move everything over a bit. Because it's just 4 simple holes, I just hand wrote the code using the G81 can cycle to initially do the spot drill at each location. Right, to change from spot drilling to through drilling, I changed the G81, which was just a single spot drill, to G83, which is now going to pick and come back out every 4mm to clear the chips. There's one more operation I need to do. These collets have got a slot milled in them as an anti-rotation feature, because otherwise, of course, as you tried to tighten up the pull tube, the whole thing would just spin. So I just need to drill a hole and tap it through here, put in a stud with a spigot on it as that anti-rotation feature. Okay, the slot is roughly 5mm and it's only a couple of millimeters deep, like 2.5. The wall's thickness here is 14. I've got an M20 screw, so I'm going to take it down to 16.5. So take 3.5mm off the end of it and then cut the threads off for the last bit. I once called this red Loctite, but it's actually supposed to be purple. It's a pretty old container, this one. Just check. Okay, that's screwed in enough, but not so far that it binds. Perfect. Well, with this adapter now finished, I can turn my attention back to the draw tube, which I screwed up last week because that thread is completely wrong. There'll be a video link up here. You can see that video if you haven't seen it already. How am I going to make a new draw tube? I made this one out of a piece of thick-walled mild steel tubing with a flange cut out and welded to the back of it. So I could do that again because I've got an offcut of that tube. However, in the meantime, since I started that draw tube, I did actually get the correct raw material to make this. And when I got that piece of steel, I also got a piece of the same stuff to make one of those. The only thing I'm a bit worried about is whereas this 35mm diameter tube fits through the forejaw and therefore I can chuck it nice and short. This 65mm steel bar is too fat to go through either of my chucks and will have a stick out of about 75mm. So I'm a little concerned about chatter, but I guess I got nothing to lose. I guess I can start off by just facing this, turning a nice round portion here to grip. I'll give that a go, and if it turns out to be a big chattery mess, I can still have another shot at it using the piece of tube. But it would be kind of nice to use this because I paid for it, and also it would allow heat treatment. The tube's just mild steel. Now, in my first attempt at a draw tube for the collets, although I needed a tool that was ground like this, I ground a tool that was like this. And I used this tool to cut this thread. Now, it's been pointed out that if I just flip it around and cut the thread down at the back of the tube with this tool, then it would be the correct geometry. However, I'm not going to do that. And the reason I'm not going to do that is I was using this tool chucked up in a collet chuck, and I had about this much stick out. And unfortunately, that caused way too much chatter. Now, these boring bars were given to me by my mate Luke, and he gave me 3 of them. So what I'll do is, for the next attempt, I'm going to switch to the shorter one. And because these boring bars have both a 90° and a 45° hole through them, if I flip this around and put this tool into the 90° hole, then it comes out very close to the grind that I need. Now, at the moment, this angle here is 40°, I guess, and this one is perpendicular and needs to be 5°. But still, it's going to take much less grinding to adjust this tool in this position. And then I'll chuck it up nice and short and hopefully avoid that chatter. Right, now I need to set up the tool and cutter grinder again. The first angle to be cut is 5°. Okay, what I didn't do last time is put a little flat on the end, which the drawing from Schaublin shows. Unfortunately, there's no dimensions for it, so I'll just have to eyeball it, but I'll set that up now and give it a quick zip over. It won't take much. Okay, let's hope this works. When you cut a normal V-shaped thread, if you just plunge your threading tool straight in each time, it will be cutting on both sides, and that often leads to a lot of chatter. So normally what you do with a manual lathe is you set your top slide across. If it's a 60-degree thread, you set your slide across 29.5 degrees so that you sort of run down one flank. So then all of the cutting only happens on the other flank. So I can do the same thing on Linux CNC. In fact, pretty much all CNC programs have like a multi-pass threading program called G76, and they'll normally have a parameter which defines that flank angle that you want to feed along. Now, because this buttress thread has flank angles of 45 degrees and 5 degrees, if I was to feed down 29.5 degrees, I'll end up taking two heavier cuts on this side, but not even touching on this side. So I'd end up with weird sort of steps or something. Now I'm doing a lot of this job using Andy Pugh's lathe macros, and there's a macro for threading. And what that's doing is pulling up this macro here, and we can see as we jump down that this line here is hard-coded with the Q of 29.5. So I'm going to need to reduce that to 4.5 degrees and save it. And I must remember to reset that after I've finished. Okay, just testing, make sure that's correct. Okay, so I'm pretty happy with that. It looks like it is running down the 5-degree infeed. Okay. That's more like it. Fits first time. Maybe a little loose, but at least there was no dicking around taking 10 cuts and going way over. Yeah, whatever. Cool. I'm going to call that a success. Meal time. Can't quite remember what I ordered. Well, they were a bit late. That job's already done. I made up a 3D printed camera stand for my action camera. I only had little 6x2, I think, magnets. So I put a bunch of those in there. It does work, but I decided to buy some stronger magnets to make it work better. So I'll print another one of those. I also noticed these things. Never used them before. For woodworking, these are the ones which drill the hole and countersink it all in once. I thought, hey, that sounds pretty handy. Plus they go straight into a bit holder. Whenever I'm doing woodworking, I always seem to need 3 drills. One to drill, one to countersink, and one to screw the screws in. This way I can use 2. One of the reasons I bought the DJI rather than a GoPro was the system of magnetic clips. It's much easier to be able to just flip the camera off from one place, move it to another place and clip it on again. I bought a couple of extra clips for it. Right, what do we got here? This is a set of just core drills for the metric tapping sizes between M3 and I think M10 or so, or M12 even. Lately, it seems for me the easiest way to get screws is just to buy these assortment boxes. And I was missing one. Oh, there it is. Now, I did a video a while ago on my switch from my worn-out battery Rode Wireless Go to the Hollyland Lark M1, which I'm currently using. And it's a good system, but there are a couple of little niggly bits about it that kind of annoy me. One is you cannot fit the dead cat on the transmitter when it's charging. So you've got to take the dead cat on and off every single time you use it. And I do tend to like using dead cats. I find I tend to breathe down through my nose and make plosives on my microphone when it's on my chest. That's one minor item, but it turns out that the DJI Mic Mini is on special at the moment. And I got it from the set from Amazon for only $100. That might seem like a lot of money for a system which I'm only expecting to address these 2 very minor items. However, when you use a system like I do nearly every single day, sometimes these littler items can be quite annoying. So I figured for $100, I'll give this a go as well. I really don't think it's necessary to put something in a plastic bag, in a plastic bag, in a box covered in a plastic bag. One other advantage is that these microphones will pair directly with the action camera without needing a receiver unit in between. Not sure how often I will use that, but it's also an extra argument. But the basic setup is that the dead cat just clips on somehow. There we go. Dead cat, with the dead cat on, you can still throw it in and charge it. And that's what I'll do. And one last feature that really sold me on this is that when you turn your camera on and off, the receiver detects that and turns itself and the microphones on and off. While we're talking about buttress threads, I got a bunch of comments last week that another place in the house that you'll always find buttress threads is on the toothpaste tube. And sure enough, I think they're right. These are probably used because it's a pretty soft, flexible plastic. But you still want a thread that's strong enough that it doesn't strip when being cranked up by a gorilla. So that's why it's a buttress thread. Okay, so that's that end finished. I can flip it around and finish off the machining. Well, not perfectly smooth. Those threads seem to have come out quite nicely. Now the through hole on this chuck is too small to accept it. So I think I'll switch to my 4-jaw. Did I ever mention that I really like cam lock fitting spindles on lathes? This is just so convenient. My mini lathe just has like a bolted flange, and my last industrial lathe, the Bolly, had a threaded spindle nose. But yeah, this is great. Right, there's only one more operation to go, and that's just to put the wrenching slots in this. Now while this would be a perfect job for an indexer, at the moment I've got no way of holding this part in my Nikken third axis. So I'll just put a stop here and manually index it around. So for milling a simple slot like this, I just use a simple looping program with a few variables in it and then just loop through them. I programmed it for a 6mm slot depth, but then I realized, wait a minute, I don't even need 4. So I stopped it after 4, just changed the program. Now to index the first side, just need to find the right stack to have the part sitting down on the jaw, but also this notch aligned. Oh wait, I didn't really think that through, because now I've cut a little bit off here. It means when I go up against my stop, I'm actually in a different place sideways than I was before. So I'll try and get this level. That looks even enough. I should have set up this stop against a portion that I didn't machine away. Oh well. Now it's reset, so now I can put it back here. Right, well that's then the parts made. Let's fit them up, see if they're going to work okay. My daughter pointed out that my time lapse looks lame once you put your hand in it, so sorry about that. Click, 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 click. Okay, well I'm pretty darn happy with how this has turned out, but I'll have to load it up with a part and see what the run out turned out like. Right, let's try something out. This is a half finished long boring bar for my Narex boring and planing head. So I've got a second one that's got a better surface finish, so let's use that one for testing. Okay, let's just get a clock on there. Now I have to see if I can remember how this works. Somewhere in here there's a 360-degree mode, but let's just go, oh, alarmed out, and I have to look that up. 3003. 3003, I've had that before. I didn't plug in the compressed air to release the brake. That was just low pressure, now it's working. So if we just jog this and see how bad my run out is. Oh wow, that sucks. It's like 0.2 of a millimeter. How on earth did I get it that bad? Rotate the part in the collet just to make sure it's not the part. That's even worse. Oh man. Okay, for the next attempt, I'll use a 20mm collet. And this is a 20mm carbide end mill, so that's probably pretty round. Okay, that's a total indicated run out of 7/100ths. Still worse than I was hoping for, but at least not as bad as with that 25mm collet. Both the 50 and the 20mm collets have had a pretty hard life, so let's try one that looks undamaged. There's a 16, I'm pretty sure I can find some 16mm end mill. After playing around with different collets and also the torque on the adapter, Now, if I loosen and retorque the screws, does this drop to the bottom and move the high spot to the other side? In which case I've got too much tolerance between my adapter and the bore. Let's try that again. Okay, that's much better. Looks like it's now down to just a bit over 3/100ths. Now where's the high spot? Okay, so the high spot's still pretty much the same. By putting it in with that at the top and tightening it up, I get down to 3/100th, which I guess I'm going to have to live with. Okay, so there we have it. It looks like I might have made the alignment boss, the 60mm here, a little bit of a loose tolerance. So that means I'm probably going to have to nudge it around and dial it in each time I want to use it. If I can nudge it down like this to 3/100ths of a millimeter total run out, that's about 1/1000th of an inch, I can live with that. Obviously would have been nicer if it was perfectly aligned and just fell into place every time, but that's not my channel. For those of you who are Patreons and members of the channel, I'm doing a live stream after this video goes live at 1 o'clock Central European time. That's GMT +2 at the moment. So I'd love to have you come and meet us there. Anyway, stick around because the video that's going to pop up here is the one that the YouTube algorithm thinks is just right for you. Thanks for watching.